2016 free response questions, picking up where we left off earlier. We got number 4, part C. We want to find a particular solution. We're given this value right here, which tells us we have the point. If f of 2 is equal to 3, that tells us that we have the point 2, 3 that we're going to plug in later when we find our value for C. So we're going to start this off. We're going to take dy dx. Oops. Dy dx. And we're going to do our separating variables. Oops. Back up a little bit here. Separate our variables and basically just go through this whole process of solving this thing for y. Alright, so a couple of steps here. Just follow along here. Again, pause, rewind, do whatever you got to do to make sure that you're not missing any of these steps. So I'm going to move the y squared over. So it's going to be 1 over y squared, which you can just write that as y to the negative 2 if you're more comfortable writing it that way. Equals, and then this, we're going to leave this as 1 over x minus 1 dx. Oops. And this is the step where we'll do our integrating. Alright, so we're going to take the integral of both sides. On the left hand side, the integral here, again, if you want to write that as y to the negative 2, then when you add 1, that becomes y to the negative first over negative 1, and then simplify that. You just get negative 1 over y for the integral there. And right hand side, whenever we have a x with a power of 1 on the denominator, that tells you you're going to have ln in there somewhere. So basically what we're left with here is an ln absolute value of x minus 1. Okay, ln absolute value of x minus 1. And basically we're going to need the absolute value there because we don't know, oops, I did it again. We don't know if this value is going to be positive or negative in there. So we're just going to leave that as absolute value for now. And we're just going to put the plus c over here. So now in this step, this is where our point from up above, that 0.23, is going to come into play here. So the y value is 3, so negative 1/3 equals ln absolute value. I'm going to plug 2 in for x, so inside here 2 minus 1 is just 1, so absolute value of 1 plus c. Alright, so in this step right here, I'm just going to simplify it over here. ln of 1, this part right here, ln of 1, this is just 0. ln of 1 is 0. So that tells me that c is just equal to negative 1/3. Alright, so I'm going to take that and plug it in right there into that step that's in red. Alright, give myself a little extra room here. Alright, so let's take and plug that in there, and then we'll solve for y. So negative 1 over y equals ln absolute value x minus 1 minus 1/3. So first thing that we need to do is we have a negative here, so I'm going to multiply everything by negative 1. So I'm left with 1 over y. All I'm going to do over here on this right hand side, instead of making it negative ln plus 1/3, I'm just going to switch those around. So I'm going to make it 1/3 minus ln absolute value x minus 1. Now there's a couple different ways that you could do this, you know, with the 1 over y. You can multiply by y and then divide by all of this. But basically, if we're trying to get this, we're trying to get the reciprocal over here, so just y. So we can do this whole right-hand side as a reciprocal. So basically just taking and saying that, well, I'm just going to say the whole numerator is 1, and just write all of this as the denominator. And if you look at their answer key and their scoring guideline, that is acceptable for your solution. So that's how I would write it. I wouldn't worry about trying to simplify that at all. You could, but it's just a waste of time. I would just leave it like that. Okay, so there's number 4, and that's everything for number 4, finishing that up from what we didn't get to finish earlier. All right, so number 5, like I said, this is something that will not be tested this year. This is something from Unit 8, so I'm just going to skip over number 5 and just jump into number 6. So for number 6, again, we have a chain rule here for part A. We want to find the line. Again, we're trying to write an equation of the line. So the first thing that we need to do is find the slope. So that's where our derivative comes in. So we need to find the derivative of k. So that means we need to find f prime g of x times g prime, g prime, let me fix that up there. So this is a chain rule, the derivative of the outside of the inside times the derivative of the inside. All right, so this is at x equals 3. So we're going to go through and look at this. So first of all, g of 3, we're basically just replacing all these x's with 3's. And I wouldn't go through and rewrite another line. Just know that this x is a 3 and this x is a 3, and then just go through and do it. So we're looking at g of 3. So we come up to our table. Here's 3. There's g of 3 is 6. So we're looking for f prime of 6 times, and the next one, g prime of 3 is 2. So that's going to be times 2. The next one here, f prime of 6. F prime 6 is 5. So that's going to be 5 times 2, which gives us 10. Now that's not our answer, that's just the slope. We need to write the equation of the line, right? So we need to make sure that we have a point. Okay, so we have the x value is 3. We need to know what's the y value for k. So the y value for k, we're going to come back to this and see what do we get when we plug 3 in. So we're looking for f of g of 3. This is what k is defined by. So g of 3, again, g of 3 is 6. So now I'm looking for f of 6. And over here, f of 6 is 4. So that means I have the point 3, 4. Okay, and the reason why we need that is because when we do our equation of a line, we need to know not only the slope that we found over here in red, right? We have the slope 10 that we plugged in here, but we also need that point for x and y. Okay, and again, you can distribute the 10 and combine like terms and do all that stuff, but again, if you look at the answer key for the scoring guidelines, all that they really wanted you to do, or that you needed to do, was add the 4 over. But you could have, if you wanted to distribute that through, which you're probably used to doing that anyway, because you did that a lot in Algebra 1, Algebra 2, whatever, this ends up giving you minus 26. But again, this is all that you really had to do for Part A. That's the only final answer that you needed there. Okay? All right, so next for Part B, quotient rule. Okay, so we're trying to find h prime. We're looking for the derivative. So when we find h prime of x, doing our derivative here. All right, so what we're looking for is low f of x, d high, which means the derivative of the top, so g prime of x, minus high g of x, d low, the derivative of the bottom, f prime of x, over the denominator squared, so that's just f of x, that quantity squared. All right, so low d high minus high d low over low squared. All right, and now we're basically just going to take this and start plugging in our numbers. All right, so this is all at 1, so you can basically just think of all these x's as 1s. So f of 1, so we're up here, f of 1 is negative 6. G prime of 1, again in our table, g prime of 1 is 8. Minus g of 1, that's 2. And f prime of 1, so we're basically using all these numbers in that top row, that's 3. Over f of 1 squared, so again, f of 1 is negative 6. Negative 6 squared is 36. Now we're just going to simplify. Negative 6 times 8, that gives you negative 48. minus 2 times 3 is 6 over 36. In as many steps as this takes you, you get a negative 54 over 36, which those are both divisible by 18, so you get negative 3 over 2. Final answer. Next, we're looking at a integral. So we're looking at the integral of f double prime of 2x. So what you need to think about here is when you're doing the integral of this, we're trying to go from something that if we were to take the derivative, we would get this. So don't just think, well, this is just going to be the f prime of 2x evaluated from 1 to 3, because if you take the derivative of this, the derivative of f prime of 2x would be f double prime of 2x, but then you would have to take the derivative of the inside would be multiplied by 2. Okay, so since that's not what we have here, we're going to need to multiply this by 1/2 in order to cancel out this 2, getting back up to that step there. So just keep that in mind, that if you do the derivative of that, you should end up with what you're looking at there. So you've got to make sure you multiply by 1/2 there. Excuse me. All right, so now we're ready to plug in 1/2 f prime of, we got to plug 3 in. So 3, we're doing 2 times x, so 2 times 3 is 6, minus f prime of, now plug in 1, 2 times 1 is 2. The calculus part is pretty much over. Now we're looking at our table, seeing what we got here. So f prime of 6, here's my f prime column, f prime of 6 is 5, minus f prime of 2, f prime 2, negative 2, negative 2. So I'm ending up with 1/2 times 7, which is 7 over 2. Final answer. Okay, so I really think that the main thing you had to look out for here was this 1/2. And again, just think about, if you take the derivative of this, will you end up with what you have inside your integral there? So that's why you got to look out for that 1/2, because that's the tricky part there. So again, if you have any questions about number 6 or that third part of number 4, send me an email or send me a comment on Classroom, and I'll answer any extra questions that you have. Just let me know then. All right, thanks.